Let's take a look at the inscribed angle relationship. To do that, though, really, we first need to start with this idea of central angles. We had defined this already and already spoken about this, but it's the idea that at the center of the circle, a central angle made up of two radii is always equal to the arc that it sits on. So that if I change this, you'll notice the central angle changes, but the arc in which it subtends that it sits on is equal as well. That's the relationship you and I know previously to this, that the central angle is equal to the arc angle. Now the one we're learning today is called an inscribed angle. Now this one I've drawn is not an inscribed angle, but I want you to, an inscribed angle means that its vertex is on the center, but I want you to watch the value that happens here in relationship to the central angle. So when I move this into the position, notice the number 45, central angle is 90. What happens if the inscribed angle was here? Notice 45 as well. Notice if it was over here, 45 as well. Now what happens if the central angle was to change? Let's change it to 66, let's say. So what do we expect it to be? The crowd cheers. 33. Let's see. So if we go into this position, 33, this position, 33, and this position, if I get there, 33. I want to take you to an example now to show you how to calculate that, but that's the main idea. This is a good typical question to practice on. First of all, the thing I want you to notice is the given angle here of 110. This is a central angle, and we've learned in a previous experience that the central angle, this one here, is equal to the arc at that it subtends. So this arc here would also be 110. The next thing to start to look for once you've obtained an arc value is, are there any other angles that sit or subtend that arc? And the answer is yes in this question. There's an angle out here, angle 1. This is called an inscribed angle and would function at exactly half the size. So this would be 55 degrees. And if you have a trained eye, you would notice that angle 3 way out here is also an inscribed angle on that same arc, and so that 110 gets halved, and this would also be 55. That gets me two of the angles very quickly. Let's see if we can get angle 2 next. Let me just clean this up a bit. So one way to do it is we knew that angle 3 was 55. The radii of a circle are equal, which makes this an isosceles triangle, and the base angles would be equal. That's an easy way to get it. Let me show you another way that would obtain the same answer, but a different path. The 110 here is a vertical angle to the other angle on the back side of 110, which is, again, a central angle. That makes this arc 110 from here to here. And guess what? The 55 degrees, or the angle that we were looking at there, this guy right here, is exactly 110. So there's two nice ways to find it, and this is a good example of how to use inscribed angles to solve problems.